Hello, good morning. Today we're going to be talking about properties of real numbers. So, a couple things we want to pay attention to in this chapter. We have the reflexive property. The reflexive property states for any number A equals A. So, how this is used, if we know that 3 is equal to 3, 9 plus 2 is equal to 3, so we can say 9 plus 2 is equal to 3. The reflexive property. It is what it is. After the reflexive property, we get the symmetric property. Symmetric property for any numbers A and B. If A is equal to B, then B is equal to A. We see right here we have 7 is 3 plus 4. Therefore, 3 plus 4 will be 7. After that, we have the transitive property. Transitive property for any real numbers A, B, and C. If A equals B and B is equal to C, therefore A is equal to C. This is a big one. This is where we do our first step of substitution, the transitive property. Transitive lets substitution work. This is used in substitution. All right, moving on to our first example. It says identify the property of equality used to justify each statement. If 13 plus 25 is 38, then 38 is 13 plus 25. That looks just like the symmetric property. Not only that, that gives it that it flips. This states that this will equal, and 38 is equal to 13 plus 25. Next, we have y plus 4 equals y plus 4. This is reflexive. Y plus 4 is equal to y plus 4. And our think about it, in part A, if 13 plus 25 is 38 and 38 is also equal to 20 plus 18, what do you know about the expressions 13 plus 25 and 28 plus 18? So we both know that these two will equal 38. Since they equal the same thing, this is going to give us the transitive property for any A, B, and C. If A equals B, so our A is 13 plus 25. So to write this, we'd go if 13 plus 25 equals 38, and 20 plus 18 equals 38, we can use the transitive property and substitution to get 13 plus 25 equaling 20 plus 18. Identify the property of equality used to justify each statement. 2 plus 7 is equal to 2 plus 7. This is reflexive. 36 is 17 plus 19. Then 17 plus 19 is 36. This is the symmetric property. Our next example says, if the amount of sugar in a recipe is equal to the amount of flour plus 2 tablespoons, and the amount of flour plus 2 tablespoons is equal to the amount of milk, then the amount of sugar is equal to the amount of milk. Write a verbal expression in the spaces. All right, so this tells us sugar, so we'll call this S, is equal to flour plus 2 tablespoons. The amount of flour plus 2 is equal to the amount of milk. Then the amount of sugar equals the amount of milk. That's true. If we take a look, they both equal this F plus 2. So since they both equal F plus 2, we can substitute that out and get sugar and milk are equal. Let A be the amount of sugar. That's just going to walk us through everything, proving the substitution method. B. This statement is an example of which property of equality? This is an example of B. So this was the transitive property. Check. The weight of a bag of oranges plus 13 ounces is equal to 5 pounds. So O plus 13 equals 5 lbs. Which quantity is equivalent to 5 pounds? We have a bag of oranges plus 13 ounces. This statement is an example of which property of equality? So we have oranges plus 13 is 5, and 5 is oranges plus 13. This would be the reflexive. Not reflexives. This is the, this was the symmetric property where we flip it. Sorry. Reflexive is equal to itself. This is symmetric. We have our think about it. Suppose the example stated if the amount of milk in a recipe is equal to the amount of sugar, and the amount of sugar is equal to the amount of flour plus 2 tablespoons, then the amount of milk is equal to the amount of flour plus 2 tablespoons. Would this still describe the transitive property? All right, so we have sugar equals, where is it? Milk is equal to sugar. M equals S. All right, the next line states the amount of sugar is equal to flour plus 2. S equals F plus 2. Then the milk is equal to the amount of flour plus 2. Yes, this would also be the transitive properties. M equals S, X equals F plus 2. Thus, M equals F plus 2. It still works. If S equals M and S equals F plus 2, there we have two S's, so we can use the property, the transitive property, to replace them. Example 3. Use the given property of equality to complete each statement. All right, so for A, it wants us to use the reflexive property. So the reflexive property means it equals itself. So y minus 21 equals y minus 21. If 24 plus 11 is 9 plus 26, and 9 plus 26 is z, all right, so we have two things equaling this 9 plus 26. A great way to do this is with highlighters. So 9 plus 26, we're going to highlight. Think of highlighters as just an easy way to do grouping symbols. So if blue goes to orange and orange goes to yellow, then Blue goes to yellow. Transitive property quantity states that if one quantity A equals a second quantity B, and the second quantity B equals some third quantity C, then the first quantity A equals the third quantity C. So this tells us that 24 plus 11 equals Z. Use the given property of equality to complete each statement. Got it. We're using transitive again. All right. So transitive, we have 43 plus 9. And 43 plus 9. All right. 10 plus 42. 10 plus 42. And this whole thing is going to equal our 52 here. All right. So by looking at this, pink is equal to blue. Blue is equal to orange. Therefore, our pink should equal the orange as well. So this will equal 52, and it works. Next up, 2m minus 1 using the reflexive property, 2m minus 1. All right. Over here, Avery says that in part B, z equals 35. Do you agree or disagree? All right. So if we take a look here in part B, z is 35. We can agree because 24 plus 11 is 35. All right, we have a couple new properties we're going to go over. First up, we have the additive identity property. A plus 0 equals 0 plus A, which is equal to A. For any real number A, the sum of 0 and A is A. All right, that's the additive identity. Then the additive inverse. This is what allows subtraction to work. For any real number and its opposite are additive inverses of each other. So we have A and negative A equals 0, 2 and negative 2 equals 0, 7 and negative 7 equals 0. These are any two numbers that equal 0. We have the multiplication, the multiplicative identitive property. This just states that for the identity 1, when you multiply anything by the identity, you get itself. So A times 1 is A, 1 times A is A. Happens right here. We have the multiplicative property of 0. This is just the great destroyer of 0, the fact that 0 will destroy anything that you multiply it by. We should all know that one. And the multiplicative inverse property, this is where division comes in. This says that for any number, A over B, where A and B are not 0, that's very important, there is exactly one number, that is B divided by A, such that when we multiply them, they reduce to 1. And these are just fractions that are opposites of each other. They cross cancel out. All right, using our properties here. All right, we're working through this. First thing it has us do is do 2 squared, which is 4. And then next up, we multiply the 8 and 2, which give us 16. 4 minus 4 is 0. 0 plus 16 is 16. At the bottom, they give us a check. So if we do this, we get 13 plus 4 plus 0, which is just 13 plus 4, which is 17. If x minus y is an example of the additive inverse property, then what must be true about the relationship between x and y? So if this is the additive inverse, then x minus y should equal 0. And y should equal x. The added inverse always means when you add these two things together, they make 0. X minus y is the same thing as also saying x plus negative y. So negative y is the same as x. Well, negative x and negative y must be the same number. Example 5, using the multiplicative identity. All right, so taking a look right here. Cancel, 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 cancel. We're left with 1 times 7. This one has just justify it. All right, their first step, they do 1 times 4. After the 4 times 1, we have 0 minus 4. Then we had 4 minus 4. Then we had 0 plus 3. What is the multiplicative identity? Why is the multiplicative identity 1 and not the same as the additive? So for multiplying, identity is the base number we get to. So for multiplication, it's 1. It can't be 0 because 0 destroys everything in multiplication. Zero times any number equals 0. That's why. The identity needs to be 1 because 1 times anything is itself. 0 times anything is always 0. Finally, using more multiplicative property, we're going to evaluate. All right. So starting at our innermost parenthesis, we're going to have 3 times 2 is 6. So we get 4 minus 6 plus 7 times 0. Uh-oh, I see this times 0. Anytime we multiply anything by 0, we get 0. So at this point, we can cross this whole thing out and just put 0. Love 0, the great destroyer. Really, though, if we paid attention right here, because that's in brackets, that counts as a number. So this is really a number times 0. So we're going to get 0. Same thing down here. This part, due to order of operations, will go off first. So 13 minus 1 is 12, but that doesn't matter because we get our 0 here. These are inverse fractions, so they will cross cancel. And we're left with 1, and we get 1. And over here it talks about before evaluating, we can look at the 0 property here because we're seeing zeros multiplied by anything. It really doesn't matter what those numbers are because 0 will still just destroy them. And this is why we have to follow the order of operations correctly. And they're just pointing out that since this was encapsulated here, we could multiply it by 0 and get that. But if we changed it, we now see that the plus 5 is outside of the parentheses. The 0 will only destroy this part right here. And that's it.